This episode of Hak5 is brought to you by domain.com.
Hello and welcome to Hak5. My name is Darren Kitchen.
I'm Shannon Morse.
It's your weekly dose of technolust. And
it is.
You have transformed.
I've transformed into a wifey.
Did it get bigger?
Yeah, it got bigger.
Hey, you know what? In fact, I can't tell you how many times I've been working on how many times have I typed out the wife pineapple? I accidentally emailed or texted my girlfriend once, and she was like, "Hey, are you come to dinner?" I'm like, "No, I got to work late on the wife pineapple." That didn't go so well. But yeah, congrats on being a wifey.
Thanks. I am so glad that whole event is over. It was awesome. Wicked. It was awesome times, but man, that's a lot of work.
Okay, so tip to you guys: don't get married, or if you do. Go down to the courthouse.
Elope if your family gives you that option. If they don't, just make your guest list really, really small.
You know, you really should just be able to say, for instance, on Facebook or something like that, just change your relationship status to married, and then it would pop up a dialogue and be like, "We've noticed by your GOIP, thing that you're in the state of California," and then just like bring in an OAuth like marriage.california.gov thing, and then just check the EULA that nobody reads, and then you type in your social, they type in their social, you hit the thing, it goes to the IRS, boom, you're married, right? Why not?
It has to be done in person.
Why? Why?
I don't know, because it's from like the 1800s.
Is it the DMV?
It's like the DMV, but for weddings. You have to actually show up at a courthouse and give them your ID, and they have to give you a paper, and then you have to hold up your hand. Your right hand, and you have to.
There you go. For real?
You have to say, "I am who I am."
That wasn't at the ceremony where Tom Merritt was officiating while wearing Google Glass. Can we get a B-roll of that? That is kind of crazy.
It was so fun, and I'm glad I did that too, because who gets that kind of point of view?
Yeah.
Anyway, we're not here to talk about weddings.
No, we're not. We're here to talk about broken pinkies.
So what happened?
I am going to a Star Trek convention, and it would be really embarrassing if I couldn't remind you all to live long and prosper.
So you're training your hands?
Training my hands. No, I jammed my pinky. So I went to the doctor and I said, "Doctor, I jammed my pinky, hurts real bad, thinking an X-ray." And he goes, "Oh, pinky looks jammed. Better hurts. Why don't you get an X-ray?"
What?
Okay, so anyway, that's two things that are messed up with the world. The medical industry and the marriage industry, which actually is an industry.
Yes, it is.
You have to pay for chairs. And
you have to pay for chairs. I paid for chairs.
This show is about tech, I promise. I promise. In fact, I had a tech experience this morning.
Did you?
Yeah, trying to, take care of some banking stuff, and I still bank in Virginia because that's where this show is from. If you're OG and been watching for a while, and so I'm emailing. So they email me this form, which to their credit, they no longer ask me to fax things, which I remind them that the fax machine was invented in. Oh, that should be a hack tip or a hack tip, a trivia question. We're gonna save it, but trust me, it's over 100 years old. And so they don't do faxes anymore. They actually email PDFs, which is like, okay, that's pretty cool. Except the PDF they wanted me to email back to them was like all sorts of sensitive information.
Oh,
and so no, it's cool, because I emailed them back and I was like, well, here's my public key. Can I get your public key so I can do this properly? And no,
it won't work. They aren't trained for OpenPGP. They aren't trained for encryption techniques.
But this is...
I know this. I was trained at that same bank. That's not how they learn things there.
This is a bank.
It is a bank, so you would think that they would be trained in proper ways to hold your secure information and how to transfer it to you. But you know what? In this case, it would be more secure for you to just call them up over the phone and tell them your secret information. Well, no, it's not like it would be
more secure.
But that's not secure either.
As a phone freak in the 90s, I would beige box lines and you would just totally hear it's analog, like easy to tap. So it's no different, like, faxing, that's all obfuscation.
Yeah.
Doing it over the phone is obfuscation. Doing it over fax is obfuscation. And what do they want me to do? Like send them, I've seen some really horrible stuff where people like make a password protected zip file and then follow up with another email with the password.
Oh, this is so bad.
Yeah, I know.
An unencrypted email. In that case, it would probably be best for you to contact the IT and tell them you want to send this over, Open PGP or whatever, GPG, PGP. I'm confused now.
Both the same thing.
And then, but you know what? Their IT department might not even use that either.
Well, yeah, this is the same industry where they have things like PCI compliance and they, implement SSL on their...
They're crazy good about implementing, credit card security and stuff like that. At least they're trying.
This is credit card information that I'm supposed to be sending to.
Oh, surprise!
Okay.
Yeah, is it that terrible?
Mm-hmm.
Yeah. Who knows how many servers it's going through before it gets to them? Who knows?
Well, you can trace what. Nah, anyway, yeah. Okay. Prism, we love you, government. You guys have the shiniest shoes.
So, obfuscation.
It is. That's all it ever is. It's not. So the difference between security and obfuscation is what? Right?
So, basically, obfuscation is this intended meaning of communication where you're willfully making something a little bit more confusing to read, or you're making it a little ambiguous. You're basically kind of making things into a garble, so that when somebody looks at your text, or they look at a picture or something, they don't actually, like a computer wouldn't be able to search for that exact description.
Sure. No,
but a person could understand what it means.
So do you remember when you were first teaching yourself HTML, right? And you would make your GeoCities or whatever you did, and so to learn, you would look at other people's code, and that's the nice thing about HTML is like everything on the web is that, so you can just view source and learn by reading other people's stuff.
Yeah, I did that all the time.
Did you ever run into, again, just like anything else can be obfuscated, so can code. And so I've seen some JavaScript that like decimates what would be some naturally some simple to read code. So
they'll make it look really, really horrible and very confusing to read, but in actuality, if you take the time and look through it, you can understand line by line, and you'll be able to understand exactly what they're talking about.
Unless it's written in Perl, in which case you're going to need a neckbeard.
I'm learning Perl. I don't have a neckbeard.
Are you for real? I'm joking about that, guys. I'm sorry.
Cool. No neckbeard here. I shaved it this morning.
We should get you an adhesive neckbeard for DEF CON.
For my coding show.
There you go.
Where we learn Perl. Oh my God. Randall Schwartz would kill me.
I'll show you the Perl poetry later. It's awesome. Hashtag awesome. Also, that probably does something.
So specifically for text, obfuscation will make text unsearchable through a computer. So like a computer generally, it looks for a dictionary term or a dictionary jargon of a whole bunch of different phrases and things like that.
There's really cool
what is
stuff
your
for this.
and stuff like that.
Have you ever used SwiftKey or some of these other like Android keyboards where you start typing and then it's recommending different words to follow up with it?
Exactly.
And that's a kind of really subtle example of, say, machine learning, where it's able to process like the way sentences are structured and words and things like that. Pretty cool.
So a computer would get confused and it wouldn't be able to find that information, but if a person is looking at a bunch of jarbled words and a bunch of information that's not spelled correctly, a person can still figure out what you're trying to say because they naturally understand that other folks might not spell things correctly. So you might read a whole sentence that's completely confusing and be like, oh, I know exactly what that means.
Like leet speak.
Like leet speak.
In fact, did you not just do a hack tip on leet speak?
I might have. Yeah, there's an Easter egg in Nmap where you can make an output file with leet speak. It's ridiculous. Anyway, watch hack tip for that. So today I decided to check out a couple of different ways that you can kind of get this technique for your text files so that a computer wouldn't be able to search it.
Okay, so
but a computer would be able to search it eventually.
Show me the how does this work?
So the first couple of ways is if you wanted to use something like Google Translate. I'm sure you've heard about this before. It's where you take something that's in English or your language of choice and you translate it into like Spanish, German, and then I don't know, whatever. Name a language? Japanese. Latin, yeah, there you go. And you switch them back and forth numerous times. Eventually, when you switch it back to English, it's going to be confusing information, but you'll get the natural phrase across.
Yeah, I used to always say, back before Google Translate, but back in the days of like Babelfish, I would say, oh, just literally translate everything from English to German to French back to English, and you'll have Shakespeare.
So we still have Babelfish around. That one lets you use about maybe 200 characters if you wanted to use that. There's also Bing Translator, which is available. This one works okay, but the website's a little crashy. And then there's Google Translate, my favorite one, where you can just put in a whole bunch of information, dictionary fun, yay. And you can put a bunch of information in there. Like say if you had a secret passphrase and you wanted to turn it into something a little bit different, you could do that, translate it into Spanish, and then and then I'll take that and I'll stick it over here, and I'll translate this into let's see Icelandic. Sure, why not? And then I'll translate this. So I'll take that and I'll put it over here, and I'll translate that back into let's trade back into English. See what happens. So let's make some fun dictionary. Coconuts are found in palm trees. Tigers and lions are found. Okay, so it pretty much got the gist of what I was saying, but
well, you should definitely do it with Latin Because
Latin. Okay.
you might as well use the NSA. That right there is a reference to TrueCrypt, which we'll come back to later.
So I'll do that. Let's see.
Have you seen the TrueCrypt stuff?
No.
There's a really wicked conspiracy theory about the words that were used on the TrueCrypt latest version when they updated the page with this horrible, looked like it was made in Microsoft Paint website telling you not to use TrueCrypt and use Microsoft BitLocker instead. And long story short, somebody decided to take the first letter of every word in the first sentence, put it together, and then space them apart. And it turns out it's Latin. That's a point of contention.
Latin.
But if you throw it into Google Translate and say, take this from Latin to English, it says something to the effect of, if you wish to use NSA.
Oh, that's
Which
funny.
is like, whoa, and everybody's like, hey, this must be a canary.
Oh, that's so
are the
messed up.
TrueCrypt developers telling us that the NSA has what, infiltrated the source code or created it and they just found out? Or, who knows? There's so many great conspiracy theories
So
about
it does
that.
look like Latin is the game changer for obfuscating your text, because now it says there are coconut trees.
Hooray.
Coconut trees in the palm trees. But anyway, that's translation. You can also use a program called FauxCrypt.
Oh, I like that.
Yeah, so this is the fun part. So FauxCrypt is basically available over at FauxCrypt.org, and it's available on Windows as well as Linux, that I can tell. I'm using it on my Linux terminal on my laptop. You just wget http://FauxCrypt.org/FauxCrypt.
Okay, so they've already made the binary for you and everything?
Yeah, the binary is already there, and then you want to make sure that you change it over to a executable file with chmod plus x FauxCrypt. I also did a whole segment on hack tips about how to do this kind of stuff too.
Bash 101 series. It's
yeah,
good
we have a whole 101 series. So fun.
All right, so and in fact, we should probably also mention that the C code is available if you want to compile this yourself. So
there's my FauxCrypt. Woo!
All right.
Okay.
Well, run it.
So the cool thing about this is basically the terminal command for this program that basically takes a text file and obfuscates it for you automatically with a little bit of garbled dictionary funness. Is you create your regular text file, and then you just type in FauxCrypt, so FauxCrypt, and then the name of your text file, and mine is on the desktop. So here it is. It's called secret.txt. So I'll do desktop/secret.txt, and then I want to create my output file. So my output file will be called moresecrets.txt.
All right, and you want to do a // in front of that because you haven't actually installed it to your path.
Yeah,
so since it's in this working directory.
Thank you, Darren.
You're welcome.
There we go. Okay, so you get input file selected, secret.txt, output file selected, moresecrets.txt, done. So now if I...
We'll cat the first one first.
Okay, so cat secret, desktop, secret.txt. Okay, so it basically just says, my name's Shannon. Here's a few passwords for use on a future in a GitHub. I'm just making this stuff up. What's my name of first cat? Orange. What's the name of Darren's first car? Maroon colored Chevy truck, because that's totally you.
Totally.
What did I name my firstborn? Batman.
Of course you did.
Because, duh.
Inquiring minds want to know.
So now if I use cat moresecrets.txt, you'll see a few differences. So some of it did not change, like welcome, hello all, and welcome. That didn't really change this episode of Hak5.
This is based on a dictionary replacement, right?
It is, yes.
So not every word is going to change.
So let's see, if we go down to first cat or nage, what is Darren's first car? Maroon colored Chevy truck. What did I name my firstborn? Batan.
So that's actually, so you're saying it like that, but when you first did this, I actually didn't notice the difference because my mind automatically, even though the letters are rearranged in the word.
You just figure somebody spelled it wrong.
Right, and actually after you start reading that kind of stuff for a while, you forget completely how that it's spelled wrong because it just, I don't know, your brain just gets
There's been psychological tests about that kind of thing, and it really does work when you read through it.
So what I find fascinating here is you had mentioned that this is to thwart, say, a computer that would analyze this and understand it.
It would be great for, like, say, if you're working in a company and you have tons of emails going back and forth between other coworkers, and they use some kind of algorithm technique to search for flagged words, for example. That would be one way that you could hide whatever you're talking about.
I absolutely noticed this. That in fact, when I was reading up on this, I actually use a screen reader because I was doing a whole bunch of other stuff, and so this TTS engine is reading back to me this this description of the program.
True.
But then, of course, the screen reader is reading it all misspelled and wrong, and it's like, wait, what is it? Now it's speaking Klingon.
So it has no clue.
However, I must say. We can't really recommend this as any sort of security. It's just obfuscation. I mean, if it's just using a dictionary,
it's not encryption.
Well, right, but if it's just using any sort of dictionary, it's just a matter of the machine learning that dictionary as well and then understanding the difference.
Sure, but who's going to do that?
It's fun.
Somebody will.
Sure. Who's going to listen into the fax machine when I fax them my credit card information?
It's fun, and that's what I like about it. It's
okay.
a fun obfuscation technique.
Well, I am down for fun.
Good.
And
Funsies.
spaceships. So
I like beer.
With that, let's go have one. Let's go take a break, and then when we get back, I'll be up in Eugene, Oregon, with Peter building drones.
If you stopped right at Eugene, that would be a little awkward. Let's do the thing.
See you guys. It doesn't matter if you're obfuscated or obfuscated. When you have that killer idea, you need to snag a domain name and some web hosting very quickly. And you can do that, in fact. You can go over to domain.com and find out that they have an amazing domain discovery system and a super easy checkout process. And you know what it all equals? It equals you having your website up and running in no time at all. Like 0 time. Like it's already up right now. You go check it. Just ping that. Just check the whois record. It's before you even registered it. Domain.com provides future domains. They might not. I'm not sure. Come back and let me know. I like domain.com. I can't begin to tell you guys how affordable, reliable, and easy to use they are and why we've been doing business with them for so long because they are so fun to do business with. They're active on social media. You can tweet them at domain.com and see that these guys are zany. These guys are fun and crazy and they love Hak5 and they want to hook you up. So that's why they came out with a very easy to remember coupon code for Hak5 viewers like you. It's called HAK5 and it spells Hak5. And with it at domain.com's checkout, you get an extra 15% off. That's amazing. So when you think domain names, think domain.com.
We're back and it's time for the trivia question of the week. The last trivia question we had on the show was Ethernet superseded which network technology? And the answer was token ring. This week's question is, Windows 95 originally was to be released in what year? You can answer that at hak5.org/trivia for your chance to win some awesome Hak5 goodies.
Peter, we are almost there. I can feel the flight almost happening. We're like ready to take off.
Yeah, we're getting really close.
Let's just start putting the props on and go.
Right? Wait. It's like we're getting there. We are really getting there.
Look, we took all of our little components here and we used some blue tape to kind of tape them down temporarily. Obviously, because things may change and we want to make sure all of this works. But look, I mean, that is totally flight ready, huh?
Yes, this is pretty much flight ready. The one thing that we still have to do, and we have to also check the directions of the motors, and we have to also calibrate the IMU so that it knows where 0 is. So the reason is that all the sensors, when they come from the factory, they have a little bit of a variation in manufacturing, as well as...
Yeah, but once it starts flying, it'll counteract all of that stuff and it'll be fine, right?
Yeah, it's like we are getting there. The software is getting better and better, so there is...
So what you're saying is giving it better information than just making assumptions.
And also we want to make sure that it works well, and we also want to see what is happening a little bit under the hood while we are doing it.
All right.
So let's postpone our excitement because it's good, but let's do it right.
Okay, well then let's pull up our, let's set up so that we can get telemetry.
So yes, so what we want is plug in what I mentioned in the last segment, the radio, and we plug it into our laptop. It just appears as a serial interface. So
yeah, it's no different than if you were to plug, like, say, a serial USB dongle into, like, a Pineapple or any other device. It's just what /dev/TTY0 or USB
0. Yes, exactly. Yeah. That's how it pops up.
That's awesome. It knows nothing of the radio link.
Yeah, we did that with the wire. Now we are doing it with the radio. So it's wireless cable. And we start Paparazzi Center. over here, and this is started. So what you select on the left here is the Bumblebee quad. It's this is what
yes.
What
so this is the example that we've put together, so everybody else can just pick it up, and they don't have to worry about mixing the motors or any of that stuff.
Because it is cross configuration. So the front is between this motor, so you need to adjust these.
Which is good because we've got this cute little canopy where the eyes want to point forward.
And when you're flying, you know where front is. It's much easier because you can see it from a distance. When you're flying out manually, obviously. Of course. So Bumblebee Quad, this is what we select. If we didn't upload the firmware, as already described earlier, we would upload the firmware, compile it. It's all already we done before when we were playing with, on the desk with it.
So we were using the DFU. It was just pushing it over DFU.
Yeah, over DFU. So you could plug in the USB cable and flash the firmware if you didn't do that before.
Oh, so, okay. So you don't even have to. You can get it all assembled and then flash it.
Yeah,
doesn't matter.
Yeah. It doesn't matter. So you could do that. So we have the radio plugged in. We should plug in the battery into the aircraft now.
Okay.
So that it starts sending out telemetry data. Where do
I am going to grab the battery from off camera.
Plug that in.
Oh, no. Here was the battery. It was in the quadcopter.
In the quadcopter.
Yeah, I think this battery might be dead.
Yeah. Let's plug it in. It will do its beepy beepy.
So I got lots of little blinking lights here.
Yeah, so when you look here on this side, you will see that the radio is blinking. So it is the red LED is showing that it is sending data. The green LED is that it has power.
Okay. So if we do this, if we look at the same dongle over here on your laptop,
you see
that it is blinking red. So it's getting data.
So yeah, this is our RxTX LED.
So if you were to pull up Minicom or your teletype of choice, you would just start getting a flow of data.
Yeah, it's binary data. It's the ground station converts that to information.
Cool. So we could actually use like Netcat or something to pipe this out into the internet, in fact.
Yeah. So what you do, you execute the standard flight serial, and then you will get the ground control station.
Okay.
So as you see here in the background is we have actually 3 programs running. The first program is Link. It is taking the data, the binary data from the dongle, and converting it to a ground network. It's a software bus. Okay. So it is distributing, taking the data and converting it to a protocol so that it can send it to the clients. So if you were connected to the same Wi-Fi I am with your laptop and started GCS, you would see the same data from this aircraft at the same time.
Cool. That's a huge, so we could have a fleet of operators.
Yeah, it's like you can monitor with several people.
And we could probably even monitor more than one at a time, more than one drone, right?
If you start more links, you plug in more than one modem, let's say, with 2 aircraft, you can plug them into the same ground network.
A Beowulf cluster of drones.
Yeah.
Nice.
So the second program is server. This is responsible mostly, the main job is actually doing logging. So it logs to a file everything that comes from
So for every single flight, it's like the black box is here, not here.
Not here. You can do that. It's like there are also hardware that has an SD card that you can plug into the telemetry port and it logs it to an SD card. It is of course possible. You can do anything you want.
Sure.
But this is our black box on the ground. And you can take those logs. There are also clients. It's all in the suite where you can replay those log data and run the flight again if you want to debug stuff.
You're like, check it out, guys. I really did do a barrel roll. Look at the flight data.
Yeah. And then we have the ground control station. So this is the thing with the map, what we showed before.
And that's where we can like set our waypoints and see the telemetry back, like where's our artificial horizon and things like that.
Yes, and there are several tabs in the center lower area of the screen, and then you have flight plan, GPS, PFD, link, MISC, and settings. We are interested in settings for now because we will be calibrating the sensors.
Okay.
So we want to switch in settings. If you look here, let's move that. You can select different telemetry modes. The default one is when you're flying and you have normal operations and you do navigation. You can choose different modes. There's a huge list here. PPM is historically named like that for the radio receiver, so you can see which sticks are you moving to confirm that the remote control is correctly connected and bound. And then you have Mach current calibration. It is, we will talk about that when we start doing autonomous flights for calibration of the current of the motors versus magnetometer. And raw sensors.
So what you're saying is we can see everything that is happening, and for most of these sensors we can calibrate our flight controller to acknowledge those and take those into consideration when it is flying.
Yes, no, definitely. And then what we are interested in is the scaled, not scaled sensors, the raw sensors.
Okay.
And let me choose that, raw sensors. And then you have the green button on the right where you send commit. No information when you pull it, drop down, and you change anything or you change values in the settings, they don't take effect until you press the green check mark.
I prefer that, yes.
So that you, oops, I changed something and things go wrong. So, and the confirmation that the autopilot received this information is the fact that on the left, it displays exactly what you have in the field. So on the left here, there we see a little bit trimmed raw sensors. Okay, so now how do we actually like really visualize these sensors? Because right now we're just looking at some values. Yes, for that we have another set of 2 tools that are part of the suite.
Really is a suite of tools, yeah.
Yes, it's the Unix approach of the problem. You have a set of tools for certain tasks that do them well. Like one task, do it well, like cut, like.
Right, and then I've played with a couple other flight controllers, and I've played with the commercial stuff, and it is one of those, you just plug it in and set a couple of variables in a nice little GUI, and then away you go. But you don't get all of that data. You don't have all of these suite of tools, and this really feels like, say, the Kali or Backtrack Linux versus Windows. You know what I'm saying?
Yeah, no, that's.
It's like the Linux approach. In fact, when you were configuring earlier, when we were configuring the Bumblebee XML, the example that everybody can use if they're using this frame, it's an XML file. It's very much like setting up an Apache server. In fact, it felt more like configuring Linux than I don't know what it was expecting anything else to be, because that's what's under the hood, right?
Yeah, no, that's.
I mean, you've got like microkernel and everything going on.
Yeah, there is an option of microkernel for this, so it is. This is exactly what is happening, and this is also the inspiration. We use Linux and we developed it on Linux, so it's like obviously we developed. It feels like a Linux itself. So what we will start here. When you look here in the left upper corner, there's a tools drop down. There's the list of a lot of tools. You see the list is quite long. Some of them are, for example, messages, and there are several tools that are implemented in 2 languages, or so you can, for example, if you want something additional to run on the network, something that adds some information or has a different display of stuff, you can just, instead of figuring out how this software that you're using, the monolithic software is designed, and try to write a plugin for that.
Sure, you could just look at the output.
The Ivy, this is how it's called, Ivy bus. There is a library for C, for Java, for anything. You take that, write a software in any language that you feel comfortable with that library, connect to the ground network, and off you go.
So I could literally just be like, I could have a bash script that is checking my altitude, and when it reaches a certain threshold, kick off another message that makes my
send an SMS
coffee pot go on. Because my quad's about to land and I'm going to want some coffee. Or something, I don't know.
That's exactly that.
That's fantastic. All right.
So what we start is messages. And this thing is a spy on our ground network. It is displaying all the packets that the telemetry is showing we are getting from the air. And we are interested in accelerometer. And we also, just because we can plot it in a graph. So we start the real-time plotter.
Okay.
So the real-time plotter, let me arrange that a little bit here. And start maybe another one. Let's start 2. Real-time plotter number 2. And there we go. and tab, and messages. So what you do, you take the value, you just drag it over, drop, and another one, second.
So you're actually doing it for all three values for this, the X, the Y, and the Z.
And Z, for the accelerometer.
Okay,
and
so
let's increase the plot speed. And you see there are 3 lines. One is pretty low, that is the Z-axis, that is the G vector. So when we when you take it off, and for example, let's show off the Z by wiggling it up and down. So you accelerate. You see the Z is moving, and then X. Oh, this is Y. Excuse me. And Z. Every single one of them is shows a squiggly line
that
here.
That is fantastic.
That moves. So we can. This is one thing that
start doing all sorts of crazy stuff.
Yeah, it's awesome. Yeah, and this plotter has a lot of power. You can set offsets, you can set additional lines, and so on and so forth. So it's actually this plotter itself is already a very powerful tool. So what we need to do our calibration for this, as we said, this server is doing the logs, and we want to create a log of accelerometer data that we can take and to create a calibration file or calibration set.
So it's not like another one where there's, some of the other ones where you flip some switches on the remote, or you hit a special calibration program.
Yeah.
This is, what you're trying to do here is log some data of what? What are we logging?
We are logging the acceleration data from the accelerometer.
Okay, so we're actually going to accelerate it in that case.
We will hold it still so that we get the max and min of every axis of the sensor, so that we know where the middle is, what the scaling is.
Oh, so it's like when you would calibrate a joystick or something, where you got to rock the joystick all the way to the extent. So it knows how far is the furthest your throttle will go up or down.
Yeah,
or
exactly.
yaw left and right and all that.
Yeah, it's like they're so far we could also add modules into Paparazzi that maybe put it on a stick, but we want to see how it is done, what works, what is inside.
Let's see it. So once we have this data.
So the first thing to do, what is a nice thing, is we are getting the data. So let's restart the server once again to start a new log file, so that we know that the newest log file with the newest date and time is the one that we need.
All right.
Let's open up the...
So you don't even have to say save as whatever. It's always logging, and it's always date stamping it.
Yeah, all the time when the server is running, it is logging to a file.
Cool.
So you don't have to remember that.
All right, so we're logging now.
And what you do dance. And
dance?
Yeah, so what we want to do is let it sit on the ground just vertically for a few seconds. Then we flip it to all the extremes and keep it on this front booms. A good thing to use is actually a carton box that you can keep it in a right angle against the floor. And then we do that for 4 directions. 2 and 3 and 4, and don't forget upside down.
Oh yeah, there we go.
And now, as you might have seen in the graph, it was showing the different extremes.
Yeah, so we want to make sure that we hit the high, the medium, and the low for all 3 axes.
All 3 axes, exactly. You can also do, to go really correct, also go 45 degrees on everything. It doesn't hurt.
Okay, so that
we will skip that for now, but if you want to be exactly perfect.
So the more data we can give it, the better.
Yeah, the algorithm will figure more things out.
Cool.
So let's stop the server. So stop logging. So we stop the server. And we go to the terminal. Let's open a new tab. We are in the Paparazzi directory. There we go. So the logs are being logged into a var subdirectory in Paparazzi.
Just as you would expect logs to be in what, /var/logs or something?
Var logs.
Great.
And in var logs, you have the list of logs that we did. And over the course of the series, actually, and we will choose the last one, namely the one from And what we need to start is actually the tool that does the calibration itself. And this is located in software, tools, calibration, calibrate.py. And then we give it the .var, logs, 1. Okay, so this is the log file, and we want to also plot the result because it is nice to see. And then we just press go.
So what it's doing right now is taking a look at all of those extremes and coming up with its idea of where the center is for this accelerometer?
Yes, that's right. It is. If you see here on the terminal, it is outputting 6 values.
Mm-hmm.
And there is for each axis there are 2 values. One value is what the neutral is,
okay.
So 0, and what the other one is what is the scale. So it means for each number.
For each number is
multiply. So how much do you have to scale the value that you're getting from it to get I think 1 meter per second.
Okay.
So this is the value that you're getting out of it. Also before that you get some initial guess, optimized guesses of what the actual value is, because it is quite a heuristic algorithm. And you see here there is a terminal or a window in SciPy that's showing which values it took, this red dots, as well as the extremes, and then you can check if your calibration actually made sense. And in our case here we have a little bit we should have gathered a little bit more information in this case. So there is in each axis. When you look at it,
I see.
So you have.
We should hold each axis for a longer period of time.
Yeah, in the center here, if you look, we should have stayed here for longer.
Okay. But we could do this again and get more numbers for it to work with. But what I'm looking is the output though is. That's just XML. That's like from the config file we were just in earlier.
Yeah, that's exactly right. So let me close that window, and we just mark this and copy. And we go into the Paparazzi Center and open up our Bumblebee Quad XML.
Okay, so do we want to edit here, or do we want to just open it in Vi? There we go.
Open edit. And scroll down to the IMU, or just find it, IMU. And here you go. Here is the accelerometer data. So we just select this, delete, and paste the new calibrated values. There we go. So this is accelerometer. The second thing would be to do the same thing. As you see here, down here, we have the magnetometer, and this is what we will do next.
Okay. So how do we do the magnometer? Magnetometer. Magnetometer.
There, I think a lot of different ways of saying it. So I already opened another plotter. Okay. So let me go to the mag raw and do the same thing and move them over. The magnetometer data. A good thing actually is to do the calibration of the magnetometer outdoors.
Really?
Outside.
Okay.
Away from your laptop.
Oh, right, because your laptop could be creating electromagnetic fields.
It's actually not.
In fact, should you take your belt off?
It's hard metal, yeah, probably.
Wow.
It's like what we are measuring are such small magnetic fields that it actually a lot of things have a lot of influence on it. Okay. So I've seen that it is useful to actually do it away from your laptop because. So
do it naked in your front yard. And you should be good.
In the dew of the morning.
Yes.
With fairies. So this is a bit different. So what
are we looking at here? I'm seeing like a lot of flashing and some lines.
Yeah, we see these lines, and these lines are showing the magnetic field vector. And we can move it. What we should do is, because these booms like to collapse, we should mount the hood on it, because we will be holding it on the...
Actually, this is the front.
Oh, this. There we go. Let's not get confused.
There we go. And so now the arms are locked in there.
Lock in there, so we can hold it on the arms and show off. There we go. So as you see, if you're rotating, the values change. Like this.
So this is its perspective of the magnetic field of the Earth?
Yes. And anything that interferes with it, obviously.
And in 3 directions. So there's, 3 magnetometers that are just all mounted in different...
So they measure, this is just 3 axes, and they measure the magnitude in each of those 3 axes. And out of that, you get a vector in the world.
Cool.
So it is not only showing a horizontal vector where it's north, it is actually, if you looked at our magnetic field here, actually the North Pole is like down into the Earth.
Right.
So it is inclined.
So does this mean if we calibrate this here in Oregon for the magnetic fields here, and then we put a really big infinite power source battery in this and send it off to fly to New York on its own, it's going to get confused along the way? Because after 3,000 miles around the Earth...
Yeah, it will be different. It's like the magnetic field will be different, so you would actually have to take it into account.
That's cool. Okay, so that's another thing to take into account. If you do a lot of world travel and you bring your quadcopter with you, you're probably going to want to make sure that... When you go down to Australia, it's going to be different.
Yeah. Into Australia, or you go to Europe from US, it's like you should... at least recalibrate your magnetometer. Otherwise, in Paparazzi, you can actually set the local inclination of the vector. So actually put there is a wiki page on it. So you, instead of recalibrating your magnetometer, because
you just tell where on Earth you are?
Exactly.
Oh, cool.
Yeah.
All right.
So what we do for the calibration is what I do. There are also different schools, or maybe.
Yeah, go ahead.
I actually take it by its 2 arms and I start rotating and just rotate with it. Just rotate it faster than you are turning, but not too fast. You want to acquire as much data as possible. And rotate and rotate and rotate. And then do the same thing by holding it by the other set of arms.
Okay.
And there we go.
All right.
I should go to Dancing with the Stars now. We have done the dance. Now we can
dance of the bumblebee.
The dance of the bumblebee, exactly. So now we take this similar approach as before, and we go to the to here and stop the server. Just stop it, and we should have a new log file.
Okay.
And this time we code the same script as before, but if you look in help, you will see some confirmation how the parameters. So P for plot, and then -S for sensor, and we are selecting Mag.
Nice.
Default is Accel, so that's why we didn't have to provide it the last time.
There we go.
But you can do it also explicitly, obviously. So let's run that, and this is going through initial gas, and bam! Now you have.
Whoa! Look at that! You can see the dance.
Yeah, exactly. So you see all this data, and this is being put on a sphere.
This is mind-blowing.
Yeah.
I can't even imagine the math on the back end that tries to figure all of that out.
Yeah, it is certain very smart people who came up with a lot of very cool math to get that done. So it is being, all these data points are being fitted to an ellipsoid and then fitted to a unity sphere, so that you have it have it adjusted if you have any hard metal or magnets, static magnets inside the cage. So that's why you have to do the magnetometer on your UAV.
I see.
Because everything that is in there will influence your magnetometer.
So if we add a camera gimbal here, we're going to have to do this again because it's affecting the way that it is sensing the magnetic field of the Earth.
Yes. That's correct.
This is so cool. I'm mind blown, and I totally see the power of this now, because like it really is like Linux versus Windows.
Yeah. You see the underpinnings of what is happening.
And once you start to do this, it starts to make so much sense, especially if you've done any server management with Linux.
Yeah, it's you understand also the commercial other products that you might be using anyways.
Right, and actually that math isn't exposed to me in those, and so you just click the little button and it does the magic thing, and you're like, okay, something happened.
Yeah.
Turns out it was math this whole time.
Yeah, it's like, oh, maybe I did something wrong and I don't understand why.
Yeah.
All right. So.
Well, considering this always logs, since the server always logs, you'll figure out why.
Yeah, this is very useful that you have the logs, and it's like you have a flight, you go into the field, you fly, then something happens unexpected, and you come back. It's like, do I have the logs? Oh yes, right, I have the logs, because they're always there.
When I was flying over the power lines, my magnetometer got all screwy.
Yeah, and then you can figure out actually what happened. It's very, very useful tool, definitely when you're playing around.
Well, okay, but we've only done accelerometer and magnetometer, and I assume now very similar to the previous one. We take the XML
and just copy over where I showed you before.
Right. And so we can't provide these in the example. Everyone has to do this themselves, because like you were saying, the magnetic fields here in Oregon are going to be different from somebody in Texas, and so they have to, and of course with their equipment as well.
The equipment, every time you buy a new autopilot, every one of them will be a little bit different.
Oh yeah, variations in manufacturing, of course.
Right, yes. It's such, we are dealing here with such little forces and little fields, and this is also so accurate. It's actually mind-blowing that we can put it in such a small space, and it works so well.
Well, but on the flip side of it, the nice thing about that example configuration that we put together for the Bumblebee is, I mean, aside from doing those calibration of those sensors, the rest of it, as far as like flying forward, the mixing and everything, it's already set up as far as like the northeast and the southwest spinning in one direction, and then the northwest and the southeast spinning in other directions, and so.
So yeah, you save yourself a lot of time if you take something that is already pre-set up for you, definitely when you're starting out.
What about the gyroscope? How do we have to calibrate that? How do we calibrate that?
In general, what almost everyone does is when you start it up, we mentioned that I think before, when you start it up, it will, in the startup, like warm up, so it will take the data and see where the zero rotation speed position is. That's actually all that is being done. The scaling, as we have with the accelerometers,
right? Because we need to know like whatever meters per second or whatever.
So if you are rotating at 3 RPM around the arm,
I'll just so hit record, and I'll do this.
Yeah.
Is this okay? Is that good enough?
Yeah. No.
Or am I going to make the data worse by doing that?
Yeah, probably it will be worse.
So how do you get a good signal? How do you get a good fix on that?
So what in general it is good enough to actually use the factory defaults.
Okay.
It's you should be fine by.
So it self-calibrates every time you turn it on, just for zero.
For the zero,
okay.
And how much the scaling is, the defaults are in most cases good enough. If you want to get it really nice, get a turntable. Get a turntable. There's
you mean like two turntables and a microphone?
Yeah, 45 RPM. you put the DSIM on it, put a battery on it, connect the telemetry. You don't need to have it in the airframe. It might be easier to put this.
Oh, good point. Good point. Because we're calibrating the sensor, not necessarily the airframe.
Yes, that's right. And there is a tool in Paparazzi. There's a lot of tools, and one of the tools is meant for that. So you can actually calibrate the scaling of a gyroscope with Paparazzi too. If you want.
Oh my gosh, this is so fantastic. And then. You know, this is good enough, though, for us to actually do a Maiden flight. So we should do that, but because I know that later on we could totally get not bogged down, but really into calculating everything, because, I mean, these are motors. They put off electric fields. We've got GPS, you know, and so the more accurate information we can give it, the better it's going to fly.
Yes, the better it will be. And so the next thing we should do is put the propellers on. So we should actually first test that the directions of the motors are.
You want to spin that guy up?
Yeah, let's do that. Let me power on the transmitter. We bound it already before, so that should be fine. If we look in the ground station here, okay, let's switch to the default, and we are in default here. So when you look on the left side, you will see what status the aircraft is in.
All right. So
let me scroll that here. Okay. So you see it is in kill. The red squares means it's kill, so nothing will spin up. We have it set here on the gear switch, so now it is in attitude mode.
Okay.
So we also
so
have
what is the startup sequence? How do we spin up the rotors?
We just put the throttle stick in a corner, and then the motors will spin up.
Oh wow! There we go.
So
Look
now
at those
they're
guys
turning.
go.
So what we do is this should spin counterclockwise. Clockwise. You just put your finger on it. It is turning very slowly, so it should,
that's
should be fine.
that's totally going clockwise.
Don't throttle up full way. Because
so if this one right here is going clockwise, then I can assume that the one diagonally from it will be doing the same. And yeah, that is clockwise, which means this is counterclockwise.
I don't know.
And this one is unhappy.
Okay, so let's check why that is. Let's pull it off.
Oh, it doesn't have any power. Okay, let's give it power.
Yeah, it's a good idea to have power.
Okay.
Now it's initialized. Yeah, we can do that again.
Okay, let's try it.
Now it's spinning.
There we go. That's counterclockwise, as is the one diagonally from it.
Yeah, you feel it under the finger. It's
which means when we go to actually put our props on, we know that, this being a pusher, we're going to want to put it on the one that's going to spin it so that it creates thrust downwards and not upwards.
That's correct.
Unless, of course, we mounted our motors upside down, which we could, but that's getting a little off topic.
So one more thing that we should do before we before we put on the propellers is actually see that the motors are reacting in the right direction. So let's keep them turning.
Okay.
And if you pull it up,
I'm already hearing a difference in them. Oh, cool.
So you will hear with your ears that which motors are spinning up and spinning down. So when I'm tilting it...
If you put it like completely sideways, oh yeah. These guys are trying to right the craft because the craft knows it's on its side. And these guys have spun lower. And so similar if you do it the other way. Oh, that is so cool.
And the same thing this way?
Yeah. It's an unhappy quad because it's just like, no!
Yeah, I want to right myself.
Get back to center.
So this is a very good test before you put on the props to see that actually it is reacting the right way. Because if you have it tilted this way and it actually wants to right itself by spinning up those motors,
oops,
you have it in your face.
Yes, which is why we do this before we put on the spinny props of death.
That's right.
All right. Well, how about we put on the spinny props of death?
Yeah, now we can.
And we go for a maiden flight right after this.
Our maiden flight.
So here we go, just a real quick maiden flight just to make sure we've got propellers turning the right way and everything's all happy. Peter, why don't you take it away?
All right, let's do it. Remote control is on.
These are less than ideal conditions as it's about to start storming, so just want to raise it up a bit.
Works?
Yeah. Seems to be flying quite well, even with the wind.
Yeah, it needs tuning.
Oh, the wobbles?
The wobbles,
yeah.
This means it's much bigger frame than what the values in the manual.
Is that so? What's causing it to do this shape?
It means that the PID controller gains are set wrongly. They can be either too high or too low. It depends on the airframe. And so we will have to adjust them to make it correct. And this will be in the example settings for Bumblebee. So you will find it in the repository. But let's land now.
All right.
And touchdown. And kill the motors.
Not bad.
So it works.
Great. Hello, welcome to Hak5. My name is Darren Kitchen, and this week we are going to end the show in what we lovingly call the D block, which is have nothing to do with it being the fourth block because it's only a 3-block show.
That's true.
That's true.
So first
with that
off,
said,
some announcements. We're going to DEF CON this year. It's August 7th through 10th, and it's going to be super happy fun times. We will have a booth.
Oh, and also before DEF CON, we will be at B-Sides Las Vegas. It is Ome's Pants, and on the 5th, well, I'll be there. I'm doing some fun stuff there, and
awesome.
Actually, it's going to be birthday weekend, really. But August 5th is historically our anniversary, and we will be turning 9. I know, we're about to be 8.
Hak5 is 9 years old.
Yeah, which means that after that, we're a binary year old, and then it's very confusing because we'll be back in our terrible 2s.
Oh boy.
Binary joke for the one there.
Oh boy.
So come on by if you're going to be in Las Vegas for the shenanigans.
Yes. We should plan
and
a party.
For saying hello to Shenanigan over here.
We should plan a party.
We absolutely should. So.
And then after DEF CON, we're going to go con crazy because you guys all know how fall is. Autumn is insane for
Oh, DerbyCon's right after that.
Yeah, DerbyCon. I think you're going to go to Tour Camp, maybe?
Tour Camp. Can I tell you guys about the amazing spiritual experience that is seeing lasers shot up into the heavens, having a GSM phone network developed for a tribal community of hackers come together to live inside of geodesic domes and give talks about amazing things and teach each other these skills, and it's just so great.
I think he's gonna cry.
I can't, words can't, it's one of those, you had to be there, man. So that is starting on July 9th, I believe, and you should go to tourcamp.org because it is America's Hacker Camp and it is amazing. So I hope to see you all there.
Yeah, so we have a fun-filled summer coming up very soon. I'm so glad I don't have a wedding to plan anymore, so I have time for video games and conventions. Nah, one is good enough. So don't forget, go over to hakshop.com to pick up all sorts of really fun hacker tools before the conventions all start this summer, so that you are prepared.
You can support us directly there. We really appreciate it. We've got fun stuff coming up. We've got HackRF. You know, there's pineapples, there's duckies, there's all sorts of good stuff going on. So of course, head over there and thank you. I can't begin to express our deepest gratitude for your continued support of this little project here. We couldn't do it without you.
Our whole 4-person, 5-person team.
It is.
Oh my gosh, we're
it's
tiny.
Like 4.5. Why do we only count you as half? Oh, the 0.5.
What? Shut up.
Why do you think it's hack point? No.
Feedback at hak5.org. If you like what you see or you hate what you see, let us know.
Yes. This has been an off-rails episode of Hak5, and we value your feedback, so let us know feedback at hak5.org, as she just mentioned, and also in the comments, and also hak5.org/follow, so you can find places to hit us up on the social media. It's kind of crazy,
and all that
and
stuff.
we really appreciate you watching. So with all of that, I am Darren Kitchen.
I am Shannon Morse.
And we are reminding you to live long and trust your technolust.
Your technolust.
Is that how it goes?
Trust your technolust.
Oh.
May the force be with you.
All right, here we go. That just about wraps up this week's episode of Hak5, and we want to remind you of a couple of amazing things. No. That just about wraps up this week's episode. We're semi-transparent. No!
Start there.
We're semi-transparent.
Ready? Breathe. And D-block.
Okay.
Do these things.
Never ends.
Alright, do the thing.
Supposed to mind meld with you. Actually, I don't want to. God, who knows what's going on up there.
Vulcan mindfuck. Or whatever it's called.
It's like Pon Far up in here. All right.